Welcome students to the series of lectures on hypothesis testing. And in this series of lectures, this is the last session on hypothesis testing because in this session, we are not going to learn any new steps. We already covered them. Rather, this is the culmination of all the steps that we have learned in the previous sessions. And now we'll put everything into practice. We'll solve a complete question on hypothesis testing. And in my opinion, if you're able to solve one question properly, then you will be able to solve any question in hypothesis testing. So here we are not talking about individual steps. We are talking about how all steps come together to solve a problem that is related to hypothesis testing. We'll combine all the steps that we have learned so far to solve one question on hypothesis testing. So let's read the question. The question is, an analyst claims that the average daily return of a stock has changed. Earlier, the stock return historically was assumed to be 1.2%. To validate this, an investor collect 36 daily returns and find that the sample mean is 1.6% and the population standard deviation is 1.5%. At a 5% significance level, test whether the average daily return has increased or not. Okay, so step number one is to define your hypothesis. What is step number one? Define your hypothesis. What is your hypothesis in this question? What is your claim in this question? What is the new claim in this question? The new claim in this question is that the average daily return has increased. But from what? From the previously assumed historical mean that is 1.2%. So that becomes your alternate hypothesis. So your alternate hypothesis would be the mean return is greater than the historical mean 1.2%. This is going to be your alternate hypothesis. And the contradictory statement is going to be your null hypothesis that the mean return is less than equal to 1.2%. This is what is written here, that the alternate hypothesis is greater than 1.2% and the contradictory statement that the mean return is less than equal to 1.2%. One thing to note, step one also define what kind of test it is. If the alternate hypothesis has greater than sign, this is going to be a right tail test. Less than sign, it is going to be a left tail test. Not equal to sign, it is going to be a both tail test. We discussed about it. Here, the sign that you see in the alternate hypothesis is greater than. So it is going to be a right tail test. A right tail test. So you'll cover the area and the right tail. The second step is to choose the distribution. We discussed in the third session of hypothesis testing. If you're testing the mean, you have to use normal distribution or t-distribution. If you're testing the variance, then you have to use chi-square distribution if the comparison is between the population standard deviation or variance with the sample standard deviation or variance. As in, you're comparing the variance of the same entity, but the population and sample variance. But if you are comparing the variance of two different entities, then you have to use F distribution. Currently, we have to use normal distribution or t distribution because we are testing the mean return. What we are testing? Average daily return. What we are testing? Average daily return. What is average? The mean daily return. The mean daily return. And that's why you calculated the mean. So you're actually comparing the population mean and the sample mean. So you have to use either normal distribution or t distribution. We also discussed if the population mean is known, if the population mean is known and the sample size is greater than 30, we use normal distribution or we use Z distribution or normal distribution. So it is going to be a normally distributed assumed sampling distribution or the hypothesis testing. In the hypothesis testing, you will choose normal distribution. Perfect. I'm using normal distribution. What is step three? Step three is to calculate your test statistics. Now, to calculate the test statistics, I have given this formula. Why this formula? We discussed about test statistics. Test statistics comes from the formula. Normal distribution, there is a different formula. T distribution, there is a different formula. For chi-square distribution, there is a different formula. For F distribution, there is a different formula. For normal distribution, the formula is X bar, the new sample mean, minus the historical mean upon the population standard deviation upon root n. And this is because of the sampling distribution. We discussed about this sampling distribution. Okay, so the new sample mean is 1.6% given in the question, 1.6%. The old is 1.2%, population standard deviation is 1.6%, and the sample size is 36. We put down the values. We got the value of test statistics as 1.60. That is your test statistics. That comes from the formula. Let's talk about the critical value. That is step 4. What is step 4? Find the critical value. Find the critical value. For the critical value, what do you have to do? You need three things for the critical value. One, the type of test. The second, the significance level. And the third is the degree of freedom. But because it is a normally distributed distribution or normal distribution, you will only use type of test and significance level. What is significance level? The area that you cover in the tail. And because it is going to be a right tail test, I'll cover only the right tail with what? The 5%, which is the significance level. What is significance level? Area in the tail. I covered it. Now I have to find out this value. To find out this value, I have to look for which table? Z table, right? Z table, because it is normal distributed discussion or the hypothesis testing. In the hypothesis testing, we are using normal distribution, so this one. But the problem, but with the problem with the normal distribution and this particular table, you're covering the area from left to right. And we are interested in this area. So we can flip the question and say, if this is 5%, then we are interested in 95% from left to right. So let's look for 95%. If I look for 95%, I'll find 95% somewhere between these two values, which is 1.6 and 4 and 5. So the value that I'll take is 1.645. That is my critical boundary. That is my critical boundary. Now, I have to compare what the critical value and the test statistics to find out whether I have rejected the null hypothesis or failed to reject null hypothesis. If my test statistics falls in this region, I will reject the null hypothesis. If my test statistics falls in this region, I fail to reject null hypothesis, or in a very simple tone, I accept null hypothesis. Let's see what the value we have. We have value which is 1.60. 1.60 falls in this region, right? This is the test statistics that we have calculated, 1.60. Let's write 1.60. So we can say that we have calculated the test statistics and the test statistics falls in the acceptance region, or we can say that we fail to reject null hypothesis. If I'm saying that I fail to reject null hypothesis, it means that currently you have taken a sample of 36 daily return and you calculated the mean return to be 1.6%. For this sample, it is greater than 1.2%. But for the next sample, it is going to be 1%. For the next sample, it is going to be 1.1%. For the next sample, it is going to be 1.3%. So on an average, it is going to be around the previously discussed or calculated historical mean of 1.2%. So 1.6% is actually not very far from the previous mean. So what is the intuition? The intuition is that at the center, you have historical mean, which is 1.2%. 1.5%, the new calculated sample mean is not very far from the center, from the population mean. So you fail to reject the null hypothesis. You failed to reject the null hypothesis, or you rejected the alternate hypothesis, saying that, hey, it's actually not very far. It's actually 1.5% is not very far from the center, because this is the boundary. This critical value is the boundary, which is 1.645. However, 1.5%, the test statistics for 1.5% is only coming as 1.60, which is not very far from the center, which is not very far from the center. And therefore, I failed to reject the null hypothesis, or I rejected the new claim that the average daily return has increased or become greater than 1.2%. Okay? Or you can also look into the alternate hypothesis and null hypothesis. I'm saying I'm failing, or I failed to reject null hypothesis. I failed to reject null hypothesis. It means that the mean return is equal to 1.2% or less than 1.2%, but it is not greater than 1.2%, which is the new claim. Perfect. So we understood that how to put all the 5 steps together and find whether your belief, the new claim, is correct or not. The new hypothesis is correct or not. So, with that, we have completed hypothesis testing. And you have to apply the same logic, whether you're testing the variance, whether you're comparing the variance of two different entity, whether you are comparing the sample mean with the population mean with the help of t-distribution. There is nothing different philosophically on in the steps. There is nothing different, whatever kind of hypothesis testing you have performed, whatever kind of distribution you're using in hypothesis testing. Okay, with that, I'll pause. Thank you. Have a nice day.